Today, I'm going to show you how to make a bioplastic using simple kitchen ingredients and explain how this ties into the chemistry of polymers, a key concept in organic chemistry and material science. For this experiment, I'm using 1 tablespoon of cornstarch, 4 tablespoons of water, 1 teaspoon of white vinegar, and 1 teaspoon of glycerin, which acts as a plasticizer. These ingredients will help us create a polymer material, a bioplastic, without using any petroleum products. As I mix everything together and heat it gently, here's what's happening chemically. Cornstarch contains long chains of glucose molecules. This natural polymer is called amylose. When heated with water, the starch granules gelatinize, meaning the hydrogen bonds between the chains loosen, allowing the polymer chains to move more freely. The vinegar, which is dilute acetic acid, helps by slightly hydrolyzing some of the starch, breaking down the polymer chains just enough to increase flexibility. The glycerin acts as a plasticizer. It inserts itself between polymer chains, reducing intermolecular forces like hydrogen bonding, which makes the funnel material less brittle and more flexible. As the mixture heats up, you'll notice it begin to thicken and become more gel-like. This increase in viscosity is a physical signal that the structure of the material is changing at the molecular level. Now here's where polymer behavior comes in. The intermolecular forces, mainly hydrogen bonds between the starch molecules, start forming temporary cross-links. These cross-links result in a semi-solid, 3D network of tangle polymer chains. It's not covalent cross-linking like vulcanized rubber, but it still creates a more rigid structure. This process is an example of physical polymer network formation, which mimics how synthetic plastics are formed, just without full chemical polymerization. So while we're not synthesizing new monomers into polymers like an addition or condensation polymerization, we are modifying and rearranging existing polymers into a new physical form with plastic-like properties. That's why the mixture becomes gel-like. You're seeing polymers in action. After the mixture thickens into a gel, I pour and shape it. As it cools and dries over the next 24 to 48 hours, it forms a solid sheet of bioplastic. This is a biodegradable polymer material, unlike conventional plastics, which are made from non-renewable petroleum-based monomers like ethylene or propylene.